Hi guys, Liz here. So this is a short summary tutorial on atomic particles, and I'm going to show you how to find out the numbers of protons, neutrons and electrons for different atoms and ions. So first thing, you're going to need a periodic table, or you can use mine if you want to follow the examples in this video. So our first example, we're going to look at a hydrogen atom, and we need to know the atomic and mass number. So on your periodic table, you'll see there's two numbers for every element. So you've got a big number, this is the mass number, and a little number, which is the atomic number. For hydrogen, both of these numbers just happen to be the same. So atomic number 1, mass number 1. Now the number of protons, that is equal to the atomic number. And the number of electrons is equal to the number of protons, which is why atoms don't have a charge, they're neutral. To get the number of neutrons, we do mass number, take away atomic number. So 1 minus 1 is 0. Our next example, copper. We find copper on the periodic table. Its big number, its mass number is 63.5. So since it's 0.5, let's round it up because you can't have half a particle. So for the purpose of this video, let's say the mass number is 64, rounded up. Its little number, the atomic number, is 29. So remember, the atomic number is the number of protons, which is equal to the number of electrons, which is why atoms are neutral. To get the number of neutrons, we subtract these, big number, mass number, minus little number, atomic number. So let's work that out. 64 minus 29 equals 35. So I can pop 35 in there. Swap hands. Okay, same thing again, platinum. Find it on the periodic table. Its big number, its mass number is 195. Its atomic number is 78. Therefore, the number of protons and electrons are 78. And to get the number of neutrons, we do the same thing again. Mass number, take away atomic number. And we get 117 for number of neutrons. Bismuth, here it is. 209 for the mass number. 83 for the atomic number. Number of protons and electrons are both 83. They're equal. To get neutrons, mass number minus atomic, so 209 minus 83 equals 126, 126 neutrons. Now we're moving on to ions. So an ion is just an atom of an element that has lost or gained one or more electrons. So generally, elements on the left-hand side of the periodic table, when they react, they lose electrons. And generally, elements on the right-hand side of the periodic table, when they react, they gain one or more electrons. So hydrogen is our first one. It's sitting with the metals, but it's not a metal, it's a gas, so it's a non-metal. Number of protons in a hydrogen ion. The only thing that's changed here is the number of electrons. The 1 plus charge tells us it's lost 1 electron. So it's still got 1 proton. It's still got no neutrons. But now it's lost its only electron. So it's got 0 electrons. Copper, we had that example here. It's still got 29 protons. This number will not change. If the number of protons changed, it would be a different element altogether. The mass number is still 64, so to get the number of neutrons in an ion, it's still 64 minus 29, which gives 35. And the number of electrons, it's lost 2 electrons because of the 2 plus charge. So 29 minus 2 gives 27. Then moving on to our negative ions. Chlorine is a non-metal. Number of protons, let's find it on the periodic table, 17. So number of electrons in a chlorine atom would be 17 as well. In the ion, it's gained 1 electron, so we add 1 onto 17 to get 18. And then lastly, to work out the number of neutrons, 36 minus 17 gives 19. So on this periodic table, the mass number was 35.5. For the purpose of this, I've just rounded it to 36, so we don't get any halves in our numbers of particles. Then we have, last example, an oxygen ion. Let's find oxygen on here. Its atomic number is 8. So the number of protons is 8. Neutrons, mass number minus atomic, 60 minus 8, that is 8. Number of electrons, that's 8 in the ion. It's gained 2 electrons because of the 2 minus charge. Add 2 onto 8, we get 10. So that is how you work out the number of atomic particles in atoms and ions. I hope you found that helpful. If you did, please like and subscribe. Thank you. Bye.